Hey there, class. We're here to learn a little bit about Ohm's law. And Ohm's law is often used in electricity quite a bit. Many of the devices that we have are what we call ohmic, and I'll describe what that means in a little bit. But basically, this is a very basic understanding of Ohm's law and the quantities that are found in it. So here's what Ohm's law states. The electric current flowing through a conductor is directly proportional to the electric potential. Electric potential is also known as voltage sometimes, or something called the electromotive force, and it's inversely proportional to the resistance. Now, one way that we can write this equation is I, which is electric current, is equal to the voltage, which again is electric potential, over the resistance. It's inversely proportional to the resistance, so resistance is here in the denominator. Now, commonly, what we'll see is Ohm's law will be written as this. V equals IR. This is one other form of it. Basically, again, the same equation. It's just solved for a different variable. But once again, this V on this side is what we call voltage. This is kind of what most people call it. This actually has quite a few names. It's sometimes known as electric potential. And if that's not confusing enough, it can also be known as a third thing. Sometimes you'll know this or see this as electromotive force. So if you're ever doing any research or anything like that, looking out about this, if you see anything talked about voltage, electric potential, or the electromotive force, they're all the same thing. When we say any of these things, we're actually talking about the exact same thing. Now, voltage is measured in the units of volts. That's our unit for voltage or electric potential. Current, that's this one, electric current. Again, is measuring the flow of electricity, how much charge is moving by a certain given part of a circuit in a given amount of time, and this is measured in something called the ampere. Sometimes known as an amp, or it's abbreviated with an A. So the abbreviation for amps or amperes is A, and I guess I should have mentioned this before, but the abbreviation for volts is the capital V. Now the last thing here, this is the electrical resistance. Resistance in a circuit is what provides kind of the slowing down effect on the electrons that are flowing. So the more resistance we have, the more slowing down we will have. And resistance is measured in an ohm. This is where, again, named after George Ohm, in his honor. The abbreviation is the Greek letter omega. So just to recap, voltage is kind of like the push in a circuit. It's what causes the electrons to move in the first place. Current, electrical current, is the actual flow. So think about like water flowing down a river. And R is the resistance, which is what kind of holds the electrons back as they're trying to flow.